about the first gas law, also known as Boyle's law. So Boyle's law is a relation concerning the compression and expansion of a gas at constant temperature. This empirical relation, formulated by Mr. Robert Boyle himself in 1662, states that the pressure of a given quantity of gas varies inversely to its volume at constant temperature. In layman's term, the pressure is inversely proportional to the volume of the gas, which means when the pressure increases, the volume decreases, and as the volume increases, the pressure of the gas decreases. Boyle's law can be expressed usefully as P1V1 is equal to P2V2, in which P1 and V1 stands for the initial pressure and volume, while P2V2 stands for the final volume and pressure.
Now let's look at some Boyle's law problems. To compress nitrogen at 1.0 atm from 750 ml to 500 ml, what must be the new pressure if the temperature is kept constant? The first volume is 750 ml and the pressure that corresponds to that volume is 1.0 atm. The volume is decreased to 500 ml and we are looking for the new pressure. All we need to do is use the equation P1V1 equals P2V2. And if we're looking for P2, we will use the formula P2 equals P1V1 over V2. So the new pressure will be 1.5 atm. Number 2. If the pressure on 6 liters of a gas is 200 kPa, what will be the volume if the pressure is doubled, keeping the temperature constant? So the pressure number 1 is 200 kPa and the volume is 6 liters. The pressure is doubled, so it will become 400 kPa and we are looking for V2. So we will use the formula V2 equals P1V1 over P2 and the answer will be 3 liters.
Good day everyone, I'm Janishan E. De La Cruz and I'm going to present our experiment named Balloon Lung. So here are the materials: 2 balloons, a clear plastic water bottle, scissors, and a thumbtack. The first thing we need to do is to take one of the balloons and cut off the bottom part, leaving you with the only top part that may resemble a very small swim cap. Second, using the thumbtack, poke a hole in the bottom. The hole doesn't need to be too large, about 2 to 3 millimeters. Next is cover the bottom of the water bottle and the hole that you just poked with the balloon you cut in step 1. Take the other balloon and put it inside the bottle. Then fold the bottom of the balloon around the rim of the bottle so the balloon hangs from the top. And lastly, pull on the bottom balloon membrane and watch what happens to the balloon inside the bottle. So as the bottom balloon is pulled down, the volume increases and the pressure decreases. But the pressures on the inside and outside of the bottle must balance. The only way to keep the pressure inside the bottle the same as the pressure outside of the bottle is to decrease the volume again. The only thing that can move to do that is the balloon on top, so it expands. This is how our lungs operate. Inside their bodies, at the base of our lungs, there is a membrane called the diaphragm. When you inhale, your diaphragm contracts and flattens out, increasing the volume and decreasing the pressure in your chest. Your lungs are like the balloon and the diaphragm is like the balloon membrane at the base of the bottle. When you exhale, your diaphragm relaxes, which decreases the volume of your lungs and increases the pressure in your chest. And that's why one of the applications of Boyle's law is our lungs.
Hey guys, I'm Brandon West Padilla and I'm about to do a Boyle's law experiment using a bottle of water and a balloon. This is the bottle of water. This is the balloon. First thing, we gonna put the balloon in the bottle, on the bottle. Just like that. So as you can see, the pressure is on the bottle, and the volume is on the balloon. So if we squeeze the bottle, just like this, the volume increases while the pressure decreases. And if we release the bottle, just like that, the volume decreases and the pressure increases. So that's the end of the Boyle's Law experiment. Thank you for watching.